So when looking at this, what I have done is I've given you guys zeros of 3 and negative 2. Now, the last example that I just went over, what we talked about is we talked about how when given a polynomial set equal to 0, we were able to solve it and we were able to find the zeros, right? So we learned how to find the zeros. And the main important thing at the end, what we found out for each 0 was x equaled this and x equaled that. So we could say if my zeros are 3 and negative 2, is it possible then to say x equals 3 and x equals negative 2? Because remember, the zeros are your x-intercepts, right? They're the value of x when the graph crosses the x-axis. So we could say for each 0, x equals these values, right? Does that kind of make sense?
So then it could just be x minus 3 and x plus 2.
For what? OK, so what we want to look at, the next thing we're looking at, remember, how did we get to these values? Well, remember, we got to these values by solving by using the zero product property. So yeah, going back to what you said is we found these because we knew that these values are when our y value was equal to 0. So what I do is I rewrite these. Right? I'm kind of like doing this. I'm pretty much doing the last exact same problem backwards. So if we have our two zeros, then how did we get them to be those zeros? Well, what we did is we had to solve them for when they equaled 0, right? Because the x-intercept is your x values when y equals 0. So now I set them equal to 0. And then you could say, well, remember, we got to this equals 0 and this equals 0 by applying the zero product property. So I can write them as x minus 3 times x plus 2 equal. Now, that was when we had them equaling the 0, right?
But couldn't it be 2x plus 4 for the x minus?
Why do you have to make it more complicated than
But put it in.
Yes, we can get into different things in there. Well, yes, there's multiple operations that you could look through with that. So now what we're going to look into, and what I'll do is I'll show you how your problem would change looking at it. So hold on. Yes. Yep. Now what we need to do is, since we have a binomial times another binomial, Dimitri, what we'll simply do is just multiply. So you guys can use your FOIL technique or whatever else you need to do, where you can say x squared minus 3x plus 2x minus 6 equals 0. And therefore, you have x squared minus x minus 6
I got it right.
equals 0. Now, here's our question, though, real quick. All right, here's the issue that we want to deal with. Yeah, I have this written equals 0 because that's how we found our zeros. But what they're asking us is, what is the polynomial, right? So in my final answer, I'm not going to say this is equal to 0, because that's how we found the zeros, right? But I'm going to say now that is going to be my rule of my polynomial f of x, or whatever they want to call your function that you're going to find. But we'll say f of x, my polynomial f of x equals x squared minus x minus 6. And again, why? Because when I set that equal to 0 and factor it, use zero product property to separate, and then solve for x, I get my two zeros, 3 and negative 2.